Hello students, today we'll discuss IB Math SL Paper 2 May 2019 Time Zone 2. In this paper you can use graphing calculator. I say can because sometimes it is better to avoid using calculator. I use TI-84+. Attention, before exam clear all RAM. How to do it? So press second, mem, choose reset 7, choose all RAM 1, and then confirm, choose second. You see TI-84+, 255 operating system, RAM cleared. We'll press clear, so our calculator is ready for exam. If something is going wrong during exam, you just press second, quit, and everything will be cleared. Right, let's go on. So my name is, let us close this window. My name is Nariman Melim. I'm located in Baku, and here you can see my mobile and email. So sources to prepare for exam: you can use booklet of Oxford 2012, and for sure you should have also Mathematic SL formula booklet, because this booklet has formulas, and this booklet will be available for you during exam. So this is the cover page. Cover page. Section A, question 1. Solution will be in lower panel. Right. A group of 7 adult men wanted to see if there was a relation between their body mass index, BMI, and their waist size. Their waist sizes in centimeters were recorded and their BMI calculated. The following table shows the result. The relationship between X and Y, here X is waist, Y is BMI, can be modeled by the regression equation Y equals AX plus B. Write down the value of A, find the correlation coefficient. I don't know why they put first A and B and then coefficient. I will do both together. To get regression coefficient, you should change mode to advanced statistics. Let's do it. So we go to mode, and here we scroll up and we have statistic diagnostics on. Statistic diagnostic on. So we go on. Done. So we clear mode, quit. Now we press statistic, start, edit 1, and here we should put data into L1 and L2 columns. So L1 will be X, L2 will be Y. So let's do it. I'll put calculator here. So first we put X, so it is 58, enter, 63, enter, 75, enter. 82, enter. 93, nothing happens. 90, okay, sorry, delete, enter. So 58, 63, 63 is wrong, so let's go up. So 63, 63, enter. 75, 82, 93, we go down. Now 98, enter. And 105, enter. Now we go to the right column, and here we put 19, 20, 22, oops, 19, 20, 19, enter. 20, enter. 22, enter. 23, enter. 25, enter. 25, 25, enter. 24, enter. And last is 26. It looks correct. Now we go to statistic, calculate linear regression. So statistics, here we choose calculate, we choose linear regression 4. So X list is L1, Y list is L2, frequency list we don't need, so we press just enter, 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 calculate, and we are getting A 0, 141, B 11.1 to 3 significant figures, and regression coefficient 0.978. So we put these values here as our answers. Finished. What if we press clear here? Clear, no problem, we can press clear. Next, use the regression equations to estimate the BMI of an adult man whose waist size is 95. So this is our function. We substitute our value A and B, then we substitute our value of waist, not waist, yes, waist, 95 centimeters, and we should get, so we just put 141, 0.141 times 95 plus 11.1 equals so I did wrong. So 0.141 times, it's slow, very slow. So 1 times 95 plus 11.1. Here I made mistake, so I should insert plus, insert, so it is second insert, plus, I press enter, and only now I'm getting 24.5, so this is my answer. I put it here, and let's go on. So this we did. Question 2. let's look at this question. So, right. Let f(x) be equal 4 minus 2 ex. The following diagram shows part of the graph, so we can see the graph. Find x-intercept of the graph. X-intercept means that our function value is 0. Method 1, rewrite. So in many cases it is easy to avoid graphing calculator as much as possible. For example, in this case we rewrite equation, divide by 2, take logarithm, natural logarithm of both sides, so we get x equal logarithm 2. So how much is logarithm 2? So we have here button logarithm 2, bracket closed, enter, 0693. So this is one method. Another method is to draw the function, so insert the function. So press y equals, insert function 4 minus 2, minus didn't work, so 4 minus 2 times we don't write, just we need second e raised 2x, go to the right, draw. So while it is drawing, so it looks correct. We need to find 0. So you see it's working, so we wait until it's working. So here it shows that it will stop working. Now we should find 0. To find 0, you press second, trace, choose second, 0, left boundary, OK, press enter. Right boundary, you should move marker to the right, press enter twice. After some time we're getting the same answer, 0693. Done. The region enclosed by the graph of x, the x-axis and y-axis is rotated 360 about the x-axis. Find the volume of the solid formed. Here I consult a booklet, and it gives me for volume of revolution from about x-axis from x equals a to x equals b, this formula. In our case, it starts from 0, finish with first 0, 0693, and we should find logarithm of pi y1 squared. So fortunately we have this function already in here, and so our calculator knows this function. So we go to second quit, and now we use alpha. Alpha windows will give us finite integral, so it is 4. Now we should put here our values. 0.693 pi and here we need to put our function squared, so we put alpha trace, we choose our function y1, and it should be squared, so we put square. Then we go to the right to x. I think we did right. Let's see what we'll get after calculation. So we get correct value 343. So this question is done. Now we come to question 3. Question 3. Here you see the tail of solution of question 2b. So look, if you want to look, you can look. But now we go to question 3. The following diagram shows the quadrilateral ABCD. So we have some information. Find BD. So BD is in triangle BDC, and we can use cosine rule because we have two sides and angle between them. So cosine rule is written here. The values of A, B, and C we know, but before using calculator you should change mode into mode from radian to degree. So we go down, press enter. Now it is degree, as you can see. So then we press clear. Okay, and then we can substitute this expression, find square root of this expression, and we find the side, it is 550. Next question. Find the area of triangle ABD. So ABD triangle, find the area of triangle we know, one side we know, angle theta, and another side we already found, so we can use sine rule, because sine rule has formula for area has sine rule. So this is section 3.6 of booklet, formula booklet, area of triangle. Rewriting this formula for C, we get 88.4, but I want to call your attention to the fact that here they write find the possible values of theta. This helps you to realize that there can be two angles. So 88.4 is this angle. So we need 1.6 degree till 90 degrees. Another angle will be symmetrical, and we should add this 1.6 to 90 to get this angle. So we have two solutions, 88.4 and 91.6. Finish this question. Question 4. Let us look at this question. AB is a sector of a circle with center O and radius R as shown in the following diagram. The angle ARB is theta. Theta is between 0 and pi over 2. The point C lies on OA and OI and is perpendicular to BC. Show that OC equals R cosine. Oh, okay. So we have right angle triangle, and for this triangle we can use a trig function. For example, here for side OC, adjacent side, we use cosine. Cosine theta will be adjacent side by hypotenuse. Hypotenuse is r. So cosine theta is OC over OB. OC equals OB cosine theta, and OB is r. So we are getting what they ask. R cosine theta. OC equals r cosine theta. Find the area of triangle OBC in terms of r and theta. Again, we use section 3.6, area of triangle through sine. Here angle is theta. One of the sides is r, another side we found is r cosine theta. Substituting these values into the formula, we get half cosine, half r squared cosine theta sine theta. C. Given that the area of triangle OBC is 3/5 of the area of sector, find theta. Right, area of sector is half TR squared. So we use information that is provided. Area of OBC equals 3/5 times area of sector. Substituting expression for a triangle OBC and area of sector, and cancelling r squared and half, we get cosine theta sine theta equals 3/5 theta. Now we should change again angle into radians, insert two function, and find intersection. For example, let's do it. So mode, again radian, enter. Now it is radian, very good. Now we go to function y equals. If you have here some function, you can clear them by clear, so you will have no function. Now we have cosine theta, so cosine x, bracket closed, sine theta, sine theta, bracket closed. Another function is we can write 3/5, for example, as alpha windows, no, alpha y equals. So we can use here brackets, enter, fraction form. Fraction form, we have 3/5. Here we have just theta, and now we go to windows, because theta is from 0 to pi over 2. Here we put 0 pi divided by 2. Let us see how the graph will look. So we press draw. This is the first graph. So we are doing this part. So we press y equals, then insert one function, insert two function, draws. Okay, draw. Right. What if we zoom in? Because it looks very small. Zoom in and press enter. So this is constant function, 3/5 of x. Ah, no, why? Strange. Something we did wrong. Let us see what we have. Cosine by sine, 3/5 of x. Second trees intersection. So we got correct answer, 0.30, 0.830. Right, okay, so here I probably used bigger range. Okay, right, correct answer, that's enough for us. Now we come to question 5. I didn't like how the graph looks. This is why I returned to question 4. And now I go to zoom and I use standard. Let us see in standard mode how the graph will look. So we see that it is oscillating. Sine, cosine oscillating. Right. And then the graph 3/5 of x in radians. Yes, straight line. I like this picture. Finished. Now I go to Windows. I know that x is from 0 to pi over 2, pi divided by 2. I realize that because y is product of sine of cosine, it will be from -1 to 1. Now let us see how the graph will look. Much better. Much better. So if you don't like your graph, go to standard and then adjust the values of domain of x and then values of range. And here we see start from 0, 0 is excluded, not included, and 1 intersection. So second trace, 5 intersection, one curve, another curve, guess, and our answer 0.83, 0. Yeah, right. So we did this question now. Next question is question 5. The population of fish in a lake is modeled by the function. Find the population of fish at t equals 10. So we just will write in y equals 0 this function, but instead of t we'll put 10. Let's do it. Okay, so we go to y equals, here we clear and clear two functions. Now we insert the value, so 1000 divided by bracket 1 plus 1 didn't work, 1 plus 24 e raised to minus 0.2, minus didn't work, minus 0.2 times 10 to the right, bracket closed. Now we go to second quit, here we need alpha trace to choose our function y1, press enter, and we get the value 235. So this question is done. Find the rate at which the population of fish is increasing at t equals 10. And then find the value of t for which population of fish is increasing most rapidly. What if we combine these two questions? So we go to y equals, here we make clear, now we need derivative. Derivative is 3. So derivative by x, our function 1000 divided by bracket 1 plus 24 e raised to minus 0.2x bracket closed, and here let's put as function x. Then we go to Windows, from 0 to 30, actually let's go to standard, 6 standard. So this is our derivative. Still calculating. Right, now we want to find second trace value at x equals 10. The value is 36.0. Very good. Now we want second trace maximum. Left boundary 0, right boundary 30. Something doesn't like. Okay, let's go to Windows. From 0 to 30. So we don't see, we see only the beginning. We don't see still calculating. Calculation is on, going. Right now, second trace maximum. Left boundary 0, right boundary 30. Good. (15.9). Even though we don't see the graph, we can find maximum. Let's save time. Let's go further. Question 6. We finished. We finished. Find the value of t for which the population of fish is increasing most rapidly. It is when derivative is maximum. So we found this maximum. Question 6. In the expansion of the following expression, find the exact value of the constant term. So this expression we should rewrite. So we rewrite it this way. So first we take out 1 over x to the 15th power. As a result, we get this expression and this expression. To have constant, we have binomial distribution. Let's look. So, for example, b is x cubed. So x cubed to the r power should be 12. Minus 12 and 12 will give us 0. It means that a equals 1 over 2, b equals x cubed, and n equals 15, and r equals 4. So we should find this combination. And how to find this combination? There are two methods. One method is to use this factorial expressions. It will be 15 over 4 15 factorial over 4 factorial over 15 minus 4, 11 factorial, or you can use the following method. So go to clear, clear, 2 times clear, write first n 15, then go to math, go to probability, find this combination 3, and now we need r. R is 4. So we have 1365, and we should divide by 2 to the 11. So let us see how much is 2 to the 11. 2048. So this finished question 6. We go to question 7. Question 7. Question 7. The vector equation of line L is given by R equals point P is the point on L that is the closest to the origin. Find the coordinates of P. R is position vector. Magnitude of this vector equals square root of square roots of coordinates as sum of square roots of coordinates. Instead of magnitude, we can use square of magnitude. And to find minimum, we have two methods. One method is easier. First derivative should be equal to 0. So we find first derivative, and we see that it is either minus 1 over 14 or minus 0.07142. Method 2 is awkward. So you write y equals, insert function, draw second, trace, find minimum. Also, you don't see the graph, you will get the value. So coordinates are given by this expression: minus 1 plus 4t, 3 plus 5t, 8 minus t, and substituting t will get this coordinate, and we give it as answer. Next is section B. Section B. In this question, distance is in centimeters and time is in seconds. Particle A is moving along a straight line such that the displacement from point P after t seconds is given by the following formula. The graph is shown. Find the initial displacement of the particle. Let us look to the solutions. So initial displacement is when time equals 0. So if we put time equals 0, we get SA equals 15 centimeters. Next question. Find the value of t when particle A first reaches point P. So we should find time of this event. Okay. let us look to the function. So y equals, if you have function here, you should create. Now we have 15 minus x minus 6x to the third power e, I didn't get e raised to minus 0.8 x. Now what we have about so they give us the graph, so we can look to values of s. It is less than 15 and time is between 0 and 25. So we'll go to Windows, we put here 0 minimum, 25 maximum. For y we have minus 15 plus 15, and we should get the graphs that they have. If I didn't make mistake, that we should get the graph that they give us. For yeah, it looks correct. And we should find this minimum, first minimum. Okay. So we have drawn function. Now, second trace, we need 0. We see that 0 is somewhere here between 2 and 3. So I put left boundary 2, right boundary 3, guess 247 seconds, correct value. Very good. Find the value of t when particle A first changes direction. So it changes direction here. Why? Because gradient negative, then positive, and gradient is velocity. So first time here. So we need to find minimum. Second trace minimum, left boundary, it's okay. Right boundary, let us walk around. Okay, enough. So right boundary we have, guess we have, and we have now the value 408 seconds. Right, okay. Find the total distance traveled by the particle in the first 3 seconds. So we need value at 3 seconds. Value at 3 seconds. So it is 269, okay, and so it is three significant figures, it is 270, and we know that it traveled also 15 and this value, so we add 15 plus 270, we get 17.7. Another particle moves along the same line, starting at the same time as particle A. The velocity of the particle is given. Given that the particles A and B start at the same point, find the displacement of function SB for particle B. So, to find displacement for particle B, we take integral. We write integral, and we know that initial coordinate is 15, so this is the function. Integral and constant is 15. Given that the particles, find the other value of t when particles A and B meet. So the graph of two functions should intersect. So we are going to use this function, and we will add our function. y2 will be a new function. y2 equals 8x minus x squared minus x squared minus x squared plus 15. And let us see when these two graphs intersect. One graph we already have. Another graph. Okay. So second finished? Not finished? Okay. Let's wait. Finished. Now second trees. Intersection is 5. So first curve, second curve, guess, and it should be 9:30 seconds. So done. This question is done. Question 9. Question 9. Question 9. Let us make right. Okay. At Penn Airport, the probability that all passengers arrive on time for a flight is 0.7. The probability that a flight departs on time is 0.85. The probability that all passengers arrive on time for a flight and it departs on time is 0.65. Shows that event A and D are not independent. So section 4.6 of booklet tell us that independent events, for them to happen, a probability that both of them happen, intersection equals product of probability. Let's check. So product of probability is 0.5, and it is not equal to the value that they give, so they are dependent. Find probability A, not D. So Venn diagram, A, D, A not D is in here, so it is 0.7 minus 0.65. Given that all passengers for a flight arrive on time, find the probability that the flight doesn't depart on time. This is conditional probability, section 5, 6. We rewrite this for conditional probability, and intersection, so we use previous result 0, 0, 5 and divide by probability of A. We get 0, 0, 714. The number of hours that pilots fly per week is normally distributed with a mean of 25 hours and standard deviation sigma. 90% of pilots fly less than 28 hours in a week. Find the value of sigma. So standardized normal value refer to the standardized normal distribution, actually inverse of it. So we should find z for which probability is 90%. So let us do it. So we switch on. Second quit. Right, okay. So second distribution, inverse normal, area is 0.90 because 90%. We refer to standardized. This is why mu is 0, sigma is 1, and it will give us the value of z. 128. Then we use this relation. X is 28, so less than 28. Mu is 25, and sigma, if you calculate, will be 234. All flights have two pilots. Find the percentage of flights where both pilots flew more than 30 hours per week. So we will find first for one pilot, probability that x is more than 30 equals 1 minus probability that x is less than 30. So we use calculator. Second distribution, normal cumulative, it is 2. So lower value is very small. So we don't put here anything. Upper value is 30. Mu is 25, so you insert these values. Mu is 25. Then sigma is 234. And let us see how much will be this probability. But we need 1 minus this. 1 minus answer. Second answer equals. So this is our probability. Because we have independent events, probability of these two events, or that the two pilots flew more than 30, we square of probability that we got. So we are going to find square of this probability. So second answer squared doesn't work, squared give us this value. This value we multiply by 100 because in percent, and we get 0.00266. So this question is also done. Now we come to question 10. Question 10. In an arithmetic sequence, u1 equals u2 equals and uk equals, find the value of k. So section 1.1, the nth term of arithmetic sequence. So we have first term plus n minus 1 common difference. To find common difference, we subtract second term minus first term, we get 0.1. Then using the formula, here by the way we have mistake, because it should be k minus 1. Substituting values, we get k equals 300. Find the exact value for sk, sum of key terms. The sum of nth term is, we use this formula because we have u1, uk, and k. Substituting values, we get 4875. Consider the terms un of the sequence such that n less than equal to k. Let f be the sum of terms for which it is not a multiple of 3. Show that f equals 3240. We will go in opposite direction. We will find the sum of terms divisible by 3. So first such term is 1.5 and last such term is 31.2. But because we have less terms, we should find what is the number of terms. So we again use the same scheme, and we have 100 terms, and their sum using the formula that we used before, but for new selection we get 1635, and difference will give us what they ask, 32.40. An infinite geometric sequence is given as a is positive integer. Find the lattice values of a such that sum is less than f. So first of all, section 1.1, sum of infinite geometric sequence is given by this formula. The nth term is given by this formula. First element is a, and common multiple is 1 over square root of 2, and we find the function sum. Okay, so the sum should be less than 32.40 or less than this value. Because it should be positive integer, we round it down, so we have a equals 948. It's not about significant figures, sorry, about integer number. Paper is over. Thank you for your attention.